This is Music Theory Fundamentals Lecture 9. Today we will discuss the intervals of sixths and sevenths. We will start with a quick review of major and minor sixths using the key signature method. We will move on to use the key signature method for major and minor sevenths. We will spend a little time discussing tritones, and then we'll move on to our third method of interval construction, which we call the rule of nines. Let's get started. As promised at the end of Lecture 8, we will start today's lecture with a quick review of minor and major sixths. Construct a major sixth above each of these pitches. We start by putting it on the staff. You can go line, 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 plus one more is a space, and space, 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 plus one more is a 9, if you don't want to count up 6 from the given pitches. Next, we examine the key signature for the lower pitch. Our first lower pitch is an E, and in the key of E major we have 4 sharps: F sharp, C sharp, G sharp, and D sharp. One of those 4 is C sharp. So in order for this to be a major sixth, using the key signature method, we need to apply that C sharp to the C that we've written. This is the interval of a major sixth. Moving on, we don't see an A sharp on our major circle of fifths, but we do see an A, which has the key signature of F sharp, C sharp, and G sharp. F sharp is one of the sharps in our key of A major. So, if A up to F sharp is a major sixth, then A sharp up to F double sharp is also a major sixth. Our answer is F double sharp. Now let's choose 2 different pitches and construct a major sixth below each. Our first pitch is a B flat, and if we're starting by putting it on the staff, we go line, line, line down to the space below that, which is a D. And then for the next one, space, 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 plus one more is the line that's a G. Using the key signature of each lower pitch, we start with D major, which has 2 sharps, F sharp and C sharp. So a D up to a B natural would be a major sixth. However, that B natural has been lowered to a B flat. That means we will also need to lower our D to a D flat in order for this to be a major sixth. Next, we take the key signature of G major, which has 1 sharp, and that's an F sharp. So a G up to an E natural would be a major sixth. However, we've got an E sharp on the staff, and we need to find a major sixth below that E sharp. So if a G up to an E natural is a major sixth, then a G sharp up to an E sharp is also a major sixth. This is a major sixth, G flat up to E flat. How could you adjust the top pitch to make it a minor sixth? We need to remember that a minor sixth is 1 half step narrower than a major sixth. So we need to bring that E flat 1 half step closer to the G flat. But we have to do that while keeping it some kind of E. That's what keeps it a sixth. What is a chromatic half step below E flat? E double flat. Now we have a minor sixth. What if we are adjusting the bottom pitch to make this major sixth into a minor sixth? Remember, minor is 1 half step narrower than major. But if we're adjusting our bottom pitch, then we need to take that G flat and move it 1 half step closer to the E flat. How can we do that? By removing our flat sign. A G natural is 1 half step higher than a G flat. We can use the key signature method to construct a major seventh above F. We put it on the staff first. You can do this by counting up 7 steps space, line, etc. Or you can use the method I prefer, which is to move space, 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 space. Now apply the key signature for F major, because F is our lower pitch, to the E. This will give us a major seventh. There is an E natural in the key signature of F major because F major has one flat, B flat. So the interval pictured above is a major seventh. Let's write a major seventh below this D. You can count line, space, down 7, or you can use my preferred method, which is to skip line, 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 line. This gives us the quantity of a seventh. Now apply the key signature for E major, because E is our lower pitch, to the D above. There is a D sharp in the key signature of E major. However, we're not looking for a major seventh below D sharp. We're looking for a major seventh below D natural. So if a D sharp down to an E natural is a major seventh, then a D natural down to an E flat is also a major seventh. Pictured above is a major seventh, with C flat as the lower pitch and a B flat above. We know this is a major seventh because a seventh above C is some kind of B, and there is a B flat in the key of C flat major. Remember, in C flat, everything's flat. Let's turn this major seventh into a minor seventh by adjusting the top pitch to make the interval 1/2 step narrower. We need to bring that top pitch, that B flat, 1 chromatic half step down, or 1/2 step closer to C flat. How do we do that? We turn that B flat into a B double flat. Now we have a minor seventh. Now we have a major seventh with an F sharp as the lower pitch and an E sharp above. We know this is a major seventh because a seventh above F is some kind of E, and there is an E sharp in the key of F sharp major. This time, turn this major seventh into a minor seventh by adjusting the bottom pitch to make our interval 1/2 step narrower. We need to bring that F sharp 1 chromatic half step up, 1 chromatic half step closer to E sharp. But remember, it still needs to be some kind of an F in order for this to be a seventh. So how can we take that F sharp and raise it by a chromatic half step? We make it an F double sharp. We've made this major seventh into a minor seventh. As we've just demonstrated, the key signature method is a very practical way to construct minor and major sixths and minor and major sevenths. Some of you may still be hoping that I'll tell you about the half-step method, and okay, if you insist. A C up to an A flat is a minor sixth. Let's count how many half steps are in that minor sixth. 1, 2, 3, 4, 5, 6, 7, 8. What if it's a major sixth? Well, we'll need to go all the way to A natural. 1, 2, 3, 4, 5, 6, 7, 8, 9 half steps in a major sixth. And because some of you are still hoping I'll give you all the half step possibilities, let's do minor sevenths next. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 half steps in a minor seventh. This is getting rather tedious, but I'll show you major sevenths next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Yes, there are 11 half steps in a major seventh. I hope I've made my point now that it's not the most practical way of constructing sixths, sevenths, etc. when you're hoping to count half steps. If you want to use this as a backup plan to check your work, fine, but I think the counting half steps method has been proven to be less practical than the key signature method. However, we are going to take a little time to learn one final method of interval construction. I call it the rule of nines. Think back to our previous lecture when we covered fourths and fifths, specifically perfect fourths and perfect fifths. In this lecture, we will discuss the 6 half-step interval that we skipped previously. Remember, we said there were 5 half-steps in a perfect fourth and 7 half-steps in a perfect fifth. So what about the one between those two? The one that has 6 half-steps. Let's find it on a keyboard first. Starting on a C and going up 1, 2, 3, 4, 5, 6. This is 6 half steps above a C. So, is it an F sharp or is it a G flat? The answer is, it's both. We can construct the interval of a C up to an F sharp, and this is called an augmented fourth. We can abbreviate that as A4 or +4 or even Aug4. And to the right, we see a C up to a G flat, which we can call a diminished fifth, abbreviated D5, or the little degree sign, which is a diminished sign with a 5 next to it, or even dim5 if you prefer. This is 2 different ways of writing an interval that sound the same but are spelled differently. When we listen to the way they sound without knowing how they're spelled, some people call this interval the devil's tritone. No, I'm not making that up. Let's find out why it has such a curious name. In the past, when I've demonstrated this tritone for the first time for classes, and I've labeled it as the devil's tritone, the response I get from students has usually been, "You've got to be kidding me, right? I mean, it's just 2 notes on the piano. How can that possibly have any sinister purpose behind it?" Well, we have to keep in mind that for centuries, really for millennia, music was passed down not by being written on a page, but orally from one person to the next, a teacher to an apprentice or to a student. And so the earliest examples we have of written music were music that was written for the purpose of being used in sacred settings in the church. Because that was the purpose of the music, there was this side purpose of music needs to be as beautiful and as sonorous and as consonant as possible, because these are the sounds that are best representative of glorifying God. Because the tritone sounds unsettled, because it sounds like it wants to either resolve inwardly or outwardly in order to reach a goal, because that sound in and of itself is not sonorous, is not consonant. This was what gave it the label of the devil's interval. There are some stories from, we'll say the Middle Ages, Renaissance period. You'll hear legends of people being excommunicated from the church because they sang or wrote an interval of a tritone. These stories are probably exaggerated, but it was considered against the rules to include those sounds in religious music of the time. Now, as music written for secular purposes became more popular, and we saw the evolution of harmony throughout the Baroque and into the classical periods, we see the interval of the tritone being far more widely accepted and normalized. This isn't a foreign concept as we look at music history as a whole. For example, a lot of our earliest written secular art music came from Western Europe. However, in 1889, the World's Fair took place in Paris. This is why the Eiffel Tower was constructed, as a celebration of this fair, celebrating cultures from all over the world. French composer Claude Debussy was in attendance at that event, and at that time, he heard the instruments of the gamelons played for the first time. These were sounds, these were scales, these were harmonies that he had not heard before, and most art music, classical music lovers hadn't heard them either. And he decided, I want to use those sounds. I want to incorporate them into the music that I write for the concert hall. So early music that he wrote in the 20th century used those scales, used those harmonies, and some people thought it was wonderful, and naturally some people found it offensive. However, if you were to hear that music today, those sounds have become so widely accepted, there would be nothing offensive to your ears in hearing them. I'm reminded of a story I heard of a woman who was a missionary in a place that was far away from what we would consider modern civilization, and this particular tribe had never seen a piano before. She told them about the piano, she tried to describe it to them, but they couldn't really grasp in their minds the concept of a piano because they had never seen one. Well, one day, someone from somewhere managed to get a piano delivered to this woman where she was working. And she was thrilled, and everybody there was thrilled for her. They had heard so much about this piano, and they couldn't wait to hear what the sound of a piano actually sounded like. So she sat down, and she played an elaborate hymn arrangement full of flourishes and scales and arpeggios and wonderful sounds and wonderful tunes. And she finished, and there was a silence. And then the people kind of shook their heads and said, "How wonderful that you finally have a piano, and how sad that you've forgotten how to play it." These sounds were dissonant to their ears. They were unfamiliar, and so it sounded to them like chaos. She took one finger and proceeded to play one of their tribal melodies. And there was an outbreak of joy as they all said, "Oh, you do remember how to play." So we have to keep in mind that these labels of dissonant or consonant, sinister or glorifying, have to be considered in context of what was going on historically at the time. Today, we hear a tritone, and there are some natural responses of, okay, that feels a bit unresolved, but we're certainly not ready to excommunicate anybody for it. Now that we've learned all about this fascinating interval, let's listen to how it sounds. It may not sound terribly offensive to you at this point, and that's okay. We hear a lot of tritones in music today. If you're wondering why we call it a tritone, it's because this interval has 3 sets of whole steps. 3 tritone tones or whole tones. I'll demonstrate on a keyboard. We are going to take each of these tritone intervals and invert them, which means turn them upside down. We can do this by moving whatever note is on top down an octave, or moving whatever note is on bottom up an octave. This time we'll move the top pitch. Let's move the F sharp and the G flat each down an octave. When we invert an augmented fourth, it becomes a diminished fifth. When we invert a diminished fifth, it becomes an augmented fourth. And this is your introduction to what I call the rule of nines. Let's learn more. I'm going to tell you what the rule of nines is here, but it might be confusing the first time I spell it out. Take some careful notes or a screenshot, and then I will explain how it works on the next page. This is the rule of nines. When an interval is inverted, turned upside down, we can subtract the quantity from 9. In other words, in a second, 2 is the quantity. In a sixth, 6 is the quantity. So we subtract that quantity number from 9. Minor becomes major. Major becomes minor. Perfect stays perfect. Diminished becomes augmented, and augmented becomes diminished. Let's find out what all of this means. Say you have an augmented fourth. We subtract that number 4 from 9, and we get the number 5. Then we look at our diagram below and see, well, augmented becomes diminished. So augmented becomes diminished, 4 becomes 5. When we turn our augmented fourth upside down, it becomes a diminished fifth. Let's say we start with a perfect fifth. Perfect stays perfect. 9 minus 5 equals 4. So when we invert a perfect fifth, we get a perfect fourth. Let's try this with a major third. Major becomes minor. 9 minus 3 is 6. So when we turn a major third upside down, when we invert it, we get a minor sixth. Now we'll do minor seventh. Can you figure out what this one is? If you answered major second, you're correct. Let's see how this might be practical in constructing wide intervals, like sevenths. Here is an E flat. How could you write a major seventh below using the rule of nines? When we invert a major seventh, we get a minor second. A minor second above E flat is F flat. We know this because we can look at a keyboard and find our E flat, go up a half step to some kind of F. F flat is our minor second, which we have previously called a diatonic half step. Now, to make this F flat a major seventh below, we have to move it down an octave. Here's our answer. Use the rule of nines to construct a minor seventh above this B sharp. Start by finding a major second, which is 2 half steps below. Then invert the interval by moving the lower pitch up an octave. Find a B sharp on your keyboard. It looks a lot like a C. Now we're going to find the pitch that has the letter name A, but it's 2 half steps down from that B sharp. What pitch is that? A sharp. An A sharp is a major second below B sharp. In order to make it a minor seventh above, we will bring that A sharp up an octave. This is the rule of nines. Try the next one on your own. Pause the video if you need more time. What is a minor seventh above this F sharp? Use the rule of nines to come up with your answer. I'll start by asking you, what interval do we get when we invert a minor seventh? If you said major second, you're correct. Now we find a major second below this F sharp. What's 2 half steps down from F sharp on your keyboard? Remember, it needs the letter name E. In this case, it's an E natural. What's our final step for this to be a minor seventh above? Bring that E up an octave. Now we have the interval of a minor seventh. You can use the rule of nines to construct any interval, though it may not always be the most practical choice. Here we will try it for a major sixth below. Check your keyboard. Go up 3 half steps. You should arrive on a G sharp. This is a minor third above, and a G sharp down the octave is also a major sixth below E sharp. One final word on interval construction. It's important to recognize how an interval changes when we keep the same quantity, the same number of intervals, such as third, fourth, fifth, sixth, etc., but we change the quality, such as major to minor or perfect to augmented, etc. We've already discussed that major is 1 half step wider than minor. So if you know what the minor interval is and you want to find the major interval, keep the same lines or spaces and adjust one of your pitches to widen that interval by a half step. What about augmented? Well, we know that augmented is 1/2 step wider than perfect. A perfect fourth can be made 1/2 step wider into an augmented fourth. A perfect fifth can also be made 1/2 step wider to an augmented fifth. Just remember to keep the same quantity, the same lines or spaces, the same letter names when you adjust your pitches to adjust the quality. Perfect, 1/2 step narrower, becomes diminished. We can take our perfect fourth or our perfect fifth, narrow that interval by a half step, and if we keep the same lines or spaces, the same letter names, we make that perfect interval into a diminished interval. Here's one that we haven't discussed yet. We can take an augmented interval that is a second, third, sixth, or seventh, and realize that it is 1/2 step wider than major. It's true, seconds, thirds, sixths, and sevenths we've discussed in terms of minor and major. But 1/2 step wider than major is augmented. We can also take a minor interval and make it 1/2 step narrower. That gives us the quality of a diminished interval. While we've learned how to spell minor sixths and major sixths, we can make a sixth augmented or diminished by making it 1/2 step wider than major or 1/2 step narrower than minor. For the upcoming written test, you will only be responsible for augmented and diminished fourths and fifths. However, seconds, thirds, sixths, and sevenths can also be augmented or diminished. Just remember that augmented is 1/2 step wider than perfect, and it's also 1/2 step wider than major. Diminished is 1/2 step narrower than perfect, and also 1/2 step narrower than minor. Let's review what we've discussed today. We started with a review of major and minor sixths. We learned about tritones, which can be spelled as an augmented fourth or a diminished fifth. We learned how to construct major and minor sevenths using the key signature method. We also learned how to construct intervals using the rule of nines and inverting them. Finally, we finished today's lecture by relating interval qualities when the quantity stays the same, but the number of half steps that separates the pitches changes. Don't forget to use your online tools to practice each of these techniques for constructing and identifying intervals.